Hello, today we're going to discuss the fundamental theorem of algebra and then do some example problems that will help you with using and understanding the fundamental theorem of algebra. For my students, this is page 64 in your notebook. It will have this title, the fundamental theorem of algebra. This is day 21 of our assignments that we've been doing, and this is student journal page 103. So the fundamental theorem of algebra, you can read this, and it's not a lot of complicated words, but it doesn't seem to make much sense to students if they just read this sentence. So there's a couple things that I want to point out. Basically what the fundamental theorem of algebra says is that a polynomial with degree n, remember degree is the largest exponent, has exactly n roots. And we've talked about that before. If you have a degree of 2, then there are 2 roots or 2 solutions. If you have a degree of 3, same thing. So it has exactly n roots. Look down here at these examples. This is a quadratic. Remember, roots are where it touches or crosses the x-axis. Most of the time, real roots are. This has 2 roots. That's a quadratic. This one has 1, 2, 3. 3 roots. That's a cubic function. This one has 1, 2, 3, 4. That's a quartic function. It has 4 roots. But this shape and this shape are the same. Does that mean this is not a quadratic, or that this one has no roots? And I know you can recall that we've said before that this is no real solution. And this is where we get to learn about what are the solutions for this. Well, the solutions are complex. That means they'll contain an I. So, although this does not cross or touch the x-axis, it does still have solutions. Look at this one. Isn't this shape similar to this shape, except for the a value would be negative in this one and positive in this one? So yes, these are both cubic functions. There are 3 solutions or 3 roots to this. One of them is real. 2 of them are complex. Now, I only have 1 dot there. Remember how we've talked about double roots? If this thing dipped down, it would touch and go back up if it would. So that would count 2 times. That's where this part of the fundamental theorem of algebra comes in. Complex roots come in pairs, and that's why this definition is up here. Complex conjugates. If you have a solution of 1 plus 2i, that automatically means, according to the fundamental theorem of algebra, that you have a solution 1 minus 2i. So we're talking about complex roots coming in pairs, and the fundamental theorem of algebra tells us that we will have this many solutions. The degree tells us how many solutions. Sometimes it's cut and dry. The 2 solutions are real. Sometimes the 2 solutions in this case are complex, which have imaginary units. And sometimes you have a mixture of real and complex roots. And although this looks like one solution, since this is a cubic function, it does have 3 solutions. 1 of them is real. 2 of them are complex, since we know complex roots come in pairs. I'm probably going to need more space than this to do these problems. I look at number 1. I've got to apply everything we've been learning. P's and Q's come from the last number, the constant, are my P's, and the first number is my... So the possible factors of 60, even though this is a negative 60, the possible factors of 60, the plus or minus will take care of that negative. Plus or minus 1, plus or minus 60. 1 times 60. 2 times 30. 3 times 20. 4 times 15, is that right? Yes. 5 times 12, and 6 times 10. And I believe that's all of them. 7 does not divide evenly into 60. 8 does not. 9 does not. 10 10 does 6 times. Okay, so yes, those are all. And then, of course, for my q, it's nice when q's like this. Q is plus or minus, whoops, plus or minus 1, because that 1 is the coefficient. So my p's divided by q's, all my possible solutions are positive 1 or negative 1, positive 2 or negative 2. These are my possible solutions since I'm dividing by 1. It took me a couple guesses, and not really guesses, educated guesses, because here's numbers that I can use to figure out which solution could work. And here you can see I tried -6, and I stopped here because I knew I was going to get a huge number and it wasn't going to give me a remainder of 0. Then I tried this solution, or -1 for a root, and it didn't work. And third time's a charm, I found 3. Let me make sure as you're on here with me. 3 times 1 is 3, 0. 3 times 0 is 0, 6 plus 0 is 6. 6 times 3 is 18. 20. Oh, this would be plus 60. Positive 60, negative 60 plus 60 is 0. So yes, that works. Now typically what we could do, and hopefully you know where I got this from. This is just our degree. Let me look back up here. You take x to the 4th and divide it by x. That would be x cubed. So our degree of 3, x cubed, 0x squared, 6x plus 20. So typically you would be able to factor this, but this isn't a typical problem, and that's okay. I'm going to have to go again and find p's and q's to see. I could either, I've got two choices. I could either find more p's and q's or different p's and q's for this, or I could try another one of these solutions with these numbers with synthetic division. The choice is totally yours, just as long as you show your work. So I'm going to, and I think I'll stop the video and then again pick it back up after I find the p's and q's. I can explain a few things once I get it up there for you. I found my p's, factors of 20, 1 times 20, 2 times 10, 4 times 5. And then my q comes from the leading coefficient, that's plus or minus 1. And then my p divided by q came from here. So now I'm going to set up synthetic division. I'm going to use 1, 0, 6, 20. And I'm going to try to find which one of these would make me have a remainder of 0. You can see that I tried 1, 2, 3, 4. The 5th time I found the answer that I was looking for. This time I know that -2 is also a root. I forgot to show you at the last segment that I did what I did with the root that I found up here. I found 3 to be a root, and now I know -2 is a root. So on my student journal page, I went ahead and put 3, and now I'm going to put -2. And then I'm going to look at the quotient that I have with that problem I was doing. So as I look at this, x cubed divided by x is x squared. So this is x squared minus 2x plus 10. Now, do we know what type of function I've created with this last quotient? This is a quadratic. Will this quadratic factor? Can you find factors of 10 that'll give you a sum of -2? And I do not believe you can. But we have not done this portion yet. No, you cannot. We do know other ways to solve a quadratic. So I'm going to go ahead and set this equal to 0. And I'm going to name A, B, and C. And I'm just going to use the quadratic formula. So I'm going to find the discriminant first. Okay, so I got -36. That's what I'm going to have for my discriminant, which tells me, hopefully you can think about that and see, it tells me that I'm going to have 2 complex solutions, which means I'm going to have an I in my answer. So I can finish this out. X equals -b plus or minus the square root of negative 36 all over 2 times a. So x equals 2 plus or minus 6i, all divided by 2. And then all 3 of these are divisible by 2. So we will reduce 1 plus or minus 3i. So my final 2 solutions, and I didn't point this out earlier, but I will. I had a little bit of space I could have used over here, but I didn't. My final 2 solutions are 1 plus 3i and 1 minus 3i. Now I have 1, 2, 3, 4 solutions, and my degree is 4. So I have satisfied that according to the fundamental theorem of algebra. Okay, we'll try the next one. I think I'll attempt to see what I can get on here, and we'll see. P's are plus or minus 1, plus or minus 125. 2 does not go into it, 3 does not go into it, 4 does not go into it, 5 does. Plus or minus 5, plus or minus 25, is that right? Yes. 6 does not, 7, 8, 9, 10. Okay, so those are my P's. My Q's are plus or minus 1. So my P divided by Q, I'll put the answers down here. Okay, and I want you to know when you're doing your work, I want to see all of this. That may look messy to you, but I've said this before in class. To a math teacher, this is beautiful. This is absolutely beautiful. This is what we want to see. We want to see all of your work, all of your thought process. This confirms to math teachers that you understand the process that you're supposed to go through. When you just give answers, it does not confirm that you understand the process. Okay, I will do the P's and Q's and come back. P divided by Q for this problem is here. I'm hoping that I guess correctly the first time, and I really am just choosing between these 2, 4, 6, 8 possible roots, possible rational roots. So I think I'm going to choose negative 5. 3, 2, 1, none. At 25. Hey, did I guess right? I think I did. It's a miracle. Guessed right on the first try. Okay, I know according to the fundamental theorem of algebra, I'm going to have 3 roots. The first root is negative 5. And then I do have x squared minus 8x plus 25 as my new function. I believe all of you can look at it at this point and see we're not going to find factors of 25 that add to give me negative 8. So I'm going to do the discriminant b squared minus 4 times a times c, just to see what my roots are going to look like. That will be 64 minus 100, which is negative 16, 2 complex roots. So x is going to equal negative b, so that's going to be 8 plus or minus the square root of negative 16 all over 2 times 1. So x is going to equal 8 plus or minus 4i all over 2, and again these are all divisible by 2, so x equals 4 plus or minus 2i. So 4 plus 2i, 4 minus 2i.